Hi everyone, welcome back. So let's start diving deeper into TensorFlow 2. Technically speaking, if we divide the entire TensorFlow platform according to the stages we discussed in machine learning project workflow, we can divide it into 3 stages. The first one is the training phase. During this, we define our artificial neural network model and train it on the given data. Also, we test the model using test data and retrain it until we are satisfied with its performance. In the next phase, we save the model to a file which can later be deployed on a production server. And the third stage is the deployment. In this, we deploy the saved model on a production server ready to make predictions on new, never-before-seen data. We are going to explain deeply what TensorFlow 2 offers for all of these stages. So let's start with the first one, which is training. Generally, the machine learning model training takes a considerable amount of time in the entire development process. With the tools and facilities provided in TensorFlow 2, you would be able to train the model in a much shorter time as compared to the traditional methods of training. So first of all, at the core of model training, we have data design and model design. Data design is actually how we prepare and provide the data to the model for training. TensorFlow provides us 2 modules, tf.data and tf.datasets. For model training, we have to perform several steps in order. Firstly, we have to format the data in a specific format our model requires. It will require several steps further, like loading the data from external sources. Then we have to clean the data. For cleaning, we once again have to perform some steps, like removing rows containing null fields, mapping categorical fields to columns, and scaling numerical values generally to the range of -1 to +1. Next, we have to perform the feature engineering to choose the feature and target variables. During this step, sometimes we need to eliminate few columns totally if they are not relevant. And finally, we have to split the data into training, testing, and evaluation sets. The functions needed for all of these operations we have to perform on data are available in tf.data module. And the tf.datasets module provides built-in datasets taken from many popular machine learning libraries ready for use in your tf.data package. There are more than 100 ready-to-use datasets divided into several categories such as audio, image, video, text, and so on. Depending on your requirements, you will load the data from one of the categories and quickly proceed to your model development. In the future, more may be added to this module. You will be able to load data from tf.data.dataset using a single program statement that also creates both training and testing sets. So this saves you a lot of effort in preparing data, and you will be able to quickly focus on model training. Great. Now let's discuss the model design. How we can design our machine learning model in TensorFlow. Now, the entire Keras API is available using tf.keras. It is a high-level API that provides standardization to many APIs used in TensorFlow 1. Using tf.keras, we will be able to take advantage of several new features added in TensorFlow 2, like eager execution. Along with the tf.keras, the other option we have is tf.estimator. The estimators are provided under tf.estimator, which is a high-level TensorFlow API. They encapsulate the various phases of machine learning projects, like model training, evaluation, predicting, and exporting the model for serving through a production server. There are several pre-made estimators available in the library, like linear classifier and DNN classifiers. Even we can build our own custom estimator. Not only this, the library provides a function called model to estimator to convert the existing model to an estimator. This is very helpful when you want TensorFlow's distributed training. Another important component comes under the training phase is the training distribution strategy. It's really important because in the entire machine learning process, the most time-consuming part is the model training. This can take from a few minutes to several days, even on very well-bred equipment. You may need lots of processing power and memory to train the model. Fortunately, TensorFlow 2 comes to your rescue here. Now we can run the model training on CPU, GPU, and TPU. Even we can distribute the training across multiple hardware. This reduces the training time substantially. And the last part we can fit under this phase is the training analysis. During the model training phase, we will need to analyze the results at different stages of the training. Based on this, we will reconfigure the network, may modify the loss functions, or try different optimizers and so on. TensorFlow provides an analysis tool called TensorBoard specifically for this purpose. It provides the plots of various matrices such as accuracy and loss, which we can widely used during model training. We will explore the TensorBoard more deeply in our later videos. Great! We learned a lot. At this stage, we covered the training phase of the TensorFlow platform, where firstly we have two options. First one is the data design, where we have two modules, tf.data, which provide us all the data-related operations like loading and cleaning the data, and the tf datasets, which provides us more than 100 datasets of different types. Then we have the training distribution strategy, where we can distribute the training on multiple hardwares like CPU, GPU, and TPU. And after that, for analysis during the model training, TensorFlow provides us the TensorBoard. Great, that's it for now. In the next video, we will talk about the next phase we defined for the platform. If you like the content of this video, thumbs up, and be sure to subscribe to my channel and hit the bell icon so you will never miss any fantastic video in the future. Thanks for watching.